Welcome to this Week 4 lecture, a parallel exercise walkthrough. Our first exercise focuses on a basic two-table equi-join.
In this exercise, our objective is to complete a simple two-table join. Let's start by pasting as a comment the original problem statement that we're going to work on as a parallel exercise, and of course use tal to start our database. And let's go ahead and run that. So now we're working on the tal schema, and once that's set for this query window, we can get rid of that. And so it says, for each order, list the order number and order date along with the number and name of the customer that placed the order. So we know we're working with two tables because we have customer names. Those have to come out of the customer table. And then we have some other data that would have to come out of the orders table. Okay, so let's just get started with a pair of separate select star queries. Select star from customer and select star from orders. And let's make a little more screen real estate with our splitter bar so we can see the results of running these two queries at the same time. So we'll highlight both of those and run them. And when we look at these side by side, we see that the first one returns 12 rows and the second one returns 8 rows. And the reason that I'm emphasizing that is I want you to develop a bit of an instinct for a blown join. We'll build our join by first building a blown join that is going to give us a Cartesian product of those 8 rows by these 12 rows in every possible combination, which is not really the proper join that we're looking to do, but it's a very common error that is made by new students and experienced DBAs alike. It's a very easy problem to create. So let's take a look at what that would look like. So what we want to do is we want to get these two tables together. So let's simply add the orders table up here in this first query and see what happens when we run this. And will that actually work? Well, sort of. Because if you take a look, what we've done is, remember the original 8 rows and 12 rows? And now we have, what the heck? 96 rows. That can't be right. So that is those 8 rows multiplied by those 12 rows in every possible combination. And the reason is that we haven't created any linking criteria for the join. And so let's see if we can narrow that down a little bit. So what we really need to do is think about what is the foreign key, primary key relationship between these two tables, and can these two tables be joined directly, or do we need an additional table, as an intermediate table? Maybe they're linked through some associative entity. In this case, there is a direct linkage, and the linkage is going to be based on the customer number. So what we need to do is we need to add a where clause here. And we need to say, hey, where the order numbers table or the orders table customer number is equal to the customer number in the customer table. So this is a more orderly, a linked join with a proper foreign key and primary key relationship. And so let's see what happens when we do that. Okay, now this is making more sense. So instead of getting every possible combination of the Cartesian product between those two tables, we're getting a grand total of 8 rows, and that kind of makes sense because we had 8 customers with a total of 12 orders, so now one customer can have many orders. This is kind of making sense. This is what we'd like to see, is something more like this. Okay, and so let's see. We're almost there, except that we didn't want every field, including, we're going to get customer number a couple times here, right? Here it is from the one table, and here it is from the other table. We certainly don't need that twice, so star is not what we want. So let's take a look at the original problem statement. The original problem statement says we want the order num, and we'd like to have the order date. And let's see. Now we need the customer num. Now we need to pick one table, because if we just say customer num, there's two possible tables that have that same field name in it. Which one are we speaking of? And so if we just go ahead and put it in there unqualified and try and go on, notice that IntelliSense says, hey, that's an ambiguous column name, sir. You need to tell me what table do you want to get that out of. And in an equi-join, it's probably not that important. If we were going to be using an outer join where we wanted, where the, some tables might have fields that don't exist, or the field would exist but don't have any data in them, then we'd need to think about, is it empty in one table and not in the other? In this case, since it is the linking criteria, it's always, it's an equi-join, it's always going to exist. So it really doesn't matter which table we get it from. Let's arbitrarily say, let's get it from orders. And now we've qualified that, the squiggly red line goes away. And let's see, so we've got the customer number, and they also wanted the customer name. And let's see, does that satisfy our original problem? Scroll back up. For each order, list the order number, order date, along with the number and name of the customer, customer num and customer name that placed the order, so that's implicit there. From customer orders with the join criteria, and let's see what our results are. And there we are, very tractable result set. So 8 rows, one for each of our customers, and customer name and the order date. Very good.
Exercise 2 starts with a two-table join, similar to that in exercise 1, and adds a date filter. Our second exercise is a simple two-table join with a date filter. Again, let's start by pasting the original problem statement as a comment at the top. And let's see, let's break this so it's a little bit more readable. All right, so for each order placed on a certain date, list the order number along with the number and name of the customer that placed it. So again, we recognize that the customer name is going to come from the customer table, and that we're going to have to get the order number and details from a second table. All right, so let's again start by developing this by looking at two separate tables. And so let's select star from customer. And in a second query, let's select star from orders. All right, make a little more screen real estate here. And we see our customers and we see our orders. And from the customer table, we want to list what? Order number is going to come from the orders table along with the number and name of the customer. So that's the customer primary key is the customer number and the name of the customer. Okay, so we got to grab the date out of the second table. So we need to get these tables joined. What relates these two tables is going to be the customer number as the foreign key and the orders table relating to the customer number as the primary key in the customers table. So let's go ahead and combine these two queries. And at this point, notice we have a blown join because we haven't put our criteria in. We're going to get a Cartesian product if we don't add the qualifying criteria. So we want to do this only for those records where the customer numbers match. So let's add the implicit join here as where orders.customer number is equal to customer dot customer number. Okay, and right now we're getting everything, but let's check and make sure that we get a reasonable number of field or records back. So if we had 12 rows in the customer table and 8 rows, we should not be getting something like 96 rows. That would tell us the join was still blown. So let's execute that. And I'm getting 8 rows back. So that seems reasonable. And now we also need to add an additional conjunction to our where clause because we want to filter this for the date. Okay, and we're going to say where the order date is equal to, and we're looking for October 15th of 2015. Little comment here. I do not have to qualify which table the order date comes out of because you'll recall that field name is only found in one of the two tables. It knows, the query optimizer knows that customer doesn't have an order date, only orders has an order date, and so this will work. It would also be entirely correct for me to go ahead and fully qualify it if I wish. So I could say orders dot order date. It's never wrong to do that, and in a large or complex query, sometimes that's useful to do because it's easier to read and less ambiguous. But again, as long as the field name is not ambiguous, it's not duplicative, there's not a second field that has that same name, then I'm not required to do that. So let's see what we get here, and a little sanity check. Am I getting only those orders that are October 15th? I am. And now we can start to whittle down only the fields that I've been asked for because, again, I need to meet the specification, and right is right and wrong is wrong. And I don't want to lose points for coming this close to getting it all right and end up getting it all wrong. So it said we are to list the order number. And again, that one's unambiguous, so I don't have to qualify it. And we need to add the customer number. Now, the customer number could be ambiguous, so watch what happens if I put the customer number in there. And IntelliSense is highlighting it, says, wait, this is an ambiguous column name. And the reason it's ambiguous because you're not telling it which table I am to get it, and there are two choices that would work. It doesn't really matter in this case because it's an equi-join, which one I'm going to get it from. If we were doing outer joins where if this was not the join key, if this was just another field and it was available in both of the tables for some reason, I'd be a little bit more careful because it might potentially be null in one and have a value in the other. In this case, it doesn't really matter. I'll go ahead and just get it out of the orders table. So let's get it out of orders.customernum. And then notice that the IntelliSense has calmed down. It doesn't have a squiggly red line under anymore. And then what else? We needed the customer name, and that is a unique field. It is only found in the customer table. And so that should be the completion of the query. And there we are. So I have the order number, the customer number, and the customer name. I'd already sanity checked the date is what it's supposed to be, even though the date is not being displayed. That is the criteria. And if I needed to check that again, if it was unclear, remember you can always go back and sanity check your work by adding it back in temporarily, run it, say, yep, indeed, that's just October 15th of 2015. And now that we have it right, don't forget to take it back out. You've checked it because the correct output has only the specified fields. We got to learn to code to the spec. And there we are. In exercise 3, we will create a subquery using the exists operator. All right, let's have at the third problem. And our third problem, actually, it's numbered 5 because our actual problem will parallel TAL 5, even though it's our third problem. And again, let's split this up so it's a little more readable. So use the exists operator to find the number and name of each customer that placed an order on October 15th, 2015. Okay, so if we're using the exists operator, it's going to be exists one query saying, does this exist in the results of a second query? So we're going to be using a subquery structure. All right. So let's take a look at the tables we'll need. And again, we're going to need our customer table. Oh, I've started a new query window and I haven't set the schema. So let's come up here and run use tal right quick. And I knew that because my IntelliSense wasn't working. There we go. So now if I say select star from and start typing, now IntelliSense is working and it recognizes that there's a customer table out there. Okay. And the second table we want, again, here in this case is going to be our orders table. And we could almost steal part of our prior solution because we know what the join criteria is for these two tables. And that is going to be the orders dot customer number equaling customer dot customer number. And it's a typical primary key foreign key join. Okay, so nothing esoteric here. And we could go ahead and test this point, make sure we're getting the basic join. There it is. Okay, so that's working happily. But we have a little twist here, and we need to get the results based on the existence of orders that have a date of October 15th. Okay, so we actually need to back this off a little bit and say, you know, let's work first with just the orders table. And let's work with the innermost query, which is the part that's going to provide the date. So I just need to find something for the join criteria from, or the exist criteria from the secondary table. So we're looking for orders. And we need the date is going to be equal 10/15/2015. Let's run this much. Okay, so here are the results. There are 3 records that are 10/15/2015 transaction dates. And now that we have this, we need to wrap it in a hug. This is going to be our subquery. And we need to find where this matches. This provides records that exist. So it's going to be where something exists, where records are found from our first query. And our first query is going to be working with the customer table. Select, let's start with everything from customer where exists these records. So we're going to get everything from orders. But we haven't tied the customers table and the orders table together. So we need to work that into the join. Okay, so let's add, in addition to this order date, the join clause. It's an implicit join, doesn't use the, in other words, it doesn't use the word join, but it is setting the equality between the two tables. So we call that an implicit join. If we actually use the keyword join, which is another syntax that we could use, and we will use in some of our queries a little later on, that would be an explicit join, okay? So we need to do this where, again, orders customer number is equal to customer number. Okay, so we're going to select everything from customer where records exist in the second query, which joins up the two tables. And the order date is this date. Okay, let's start by running that. We should get, remember, 3 records, but now what we should see here are all the customer fields as well. And I have a blown syntax here. I left the end of query marker inside the semicolon or inside the parenthesis. Let's fix that. Okay, so that looks correct, but we now need to pare it down, and we're only looking for the customer number and the customer name. So notice that we have 2 records, and before we had 3 records, but there are only 2 customers. So was it the case that one of our customers made 2 purchases on the same date? And yeah, that's going to be the explanation for that. And we could check that pretty easily. Let's go back to our last solution. And we'll just paste in our last solution and run that as a check. Okay, so notice that Almonton General Store 586 had 2 purchases on that date. Okay, so now we start to see what the exists does. Why would we use this structure rather than this other structure? Here we're getting duplicative results, and we could try and filter that out with a distinct. Except look, the order numbers would make the rows distinct, so distinct is not going to filter that down. We actually need a clever twist in order to get only the customer name and customer number of those who placed 1 or more orders on October 15th. So it's subtle, but that's why we need the exists and why we're using a subquery. And run it again, and we can see, okay, so here is the answer to the question: what customers placed at least 1, but possibly more orders on October 15th, 2015? Give me their customer number and their customer name, and this is the solution. And again, this is generating the set. We look to see if those records exist. This clause is giving me the linkage between the 2 tables so that my customer can be found having the customer number that also is in the existent result set. Exercise 4 addresses a multi-table join of more than 2 tables. All right, our 4th exercise we're going to use parallel number 7 from the TAL problem set, and it states for each order, list the order number, order date, item number, description, and category for each item that makes up the order. And the challenge here is that we're now doing a join that is going to involve more than just 2 tables. So let's take a look and see how many tables are we going to need in order to get this all connected. And so let's look at our database. And in TAL, here are our tables. And we're going to need, for each order, list the order number. Okay, so the order number can come out of orders, right? That's one place we'll need. So let's list the tables. So we'll need the orders table. We're going to need the order date. And let's take a look at the columns in orders. So it also has the orders date. So that's also coming out of orders. The item number, however, of the thing being ordered, where can we get the item number? And so one of the places we can get the item number is from items. Is there anywhere else? Does orders link that? Orders does not, but order line may, and indeed it does. So where we can see that. So I might use either order line or items. Okay. And what else do we need? The description. Okay, so the description definitely comes from items. Okay, so I'm definitely going to need items. I may need order line. And the category, let's see, the category, does that come also from the items? So let's take a look in the items table. That's, yeah, the category is here in the item table. All right, so I'm going to need orders and items, anything from order line. And this requires a little bit of thought. So I can get the order num elsewhere. I can get the item num elsewhere. Do I need the number ordered? I do not. Do I need the quoted price? I do not. So why can I not just use items and orders and do this as a two-table join? Well, let's take a look. Is there anything that will relate orders to items? So if I look at the fields available in the orders table, I have an order num and an order date and a customer num. So there is a relationship between the customer and the orders table, but I'm going to need some stuff out of items, and I'm not seeing a linkage here. Well, let's go look at it the other way around. How about from the items table? So if I look in the items table, I have the item number, description, on-hand, category, storehouse, and price. Boy, I don't see any foreign keys here. It must be that our primary key, item number, is used as a foreign key to link tables elsewhere. This is where the order line comes in, and understanding the data model is important. So the order line is the line items for every order, and that provides the linkage of the item number being ordered to the order number on which the customer placed the order for that item. And one order can have one or many items, and one item can be on one or many orders. So this is a bridging table. All right, so I'm definitely going to need all three of these tables. So let's go ahead and structure our select. Let's start with select star from, and let's just list all of these tables. And they can be listed in any order, but it's helpful, I think, to list them in the order that we walk down the linkages between the tables. So orders relates to order line, order lines relates to items, and so that's how our linkage is going to be. And again, right now, if I were to run this, I would get a result, but it would have a horrendous number of lines in it because it's going to do a Cartesian join, a Cartesian product between those. Let's go ahead and do that. Let's see, items, okay, item table. And I've got 1,440 rows, which for our little sample data set, intuitively ought to know, hey, that's just not reasonable. We have a blown join. Okay, so I need to walk down the relationship. So the first question is, what's the relationship between orders and order line? So let's say where orders dot, and what could it be? Customer number, order date, order number. It must be order num that we're going to link them on, equals order line dot order num. Now again, don't jump the gun. We still have a blown join. We have 2 of the 3 tables joined. So we ought to see, if you were to count it by the equal signs, if there are 3 tables, there's going to be 3 minus 1 equal signs. If I only have 1 equal sign, that means I've left half of the table, or one of the tables, orphaned and not joined. And again, if we execute this, it executes, but now I'm getting 180 rows. And again, your instincts ought to tell you, hey, that's just not reasonable. I've still got a blown join in here. So let's continue to walk down the join and say, well, let's see, we used orders to order line. Now I need a linkage of order line something equals item dot something. Okay, well, what can our order line something be that's going to relate to items? Well, item number is going to link those two. So to that, between that and item dot item num. Now let's see if our join looks more reasonable. Okay, 12 rows. Okay, for our little sample data set, I'm buying it. That makes a lot more sense. And now we need to start addressing the fact that we've not yet complied with specification. We've given it a whole bunch of fields in the result, and we were originally asked for just a few. So for each order, list the order number. Okay, so order number and self-test. Why am I getting a squiggly line here? If I put my mouse over it, you tell me, this is a pop quiz, what is the error going to be? It's going to be an ambiguous column name because there's 2 tables that have order num in them. So which one do you want to get them from? Let's go ahead and use the first table. How about orders.order num? And then we want order date. And when I hit this, the comma, am I going to get an error or not an error? Again, quick self-test. Think about it. No error, and the reason is because order date only appears in one of the fields, so or one of the tables. I don't have to fully qualify it. Of course I can. It's always okay to fully qualify the field name, but it works here without it because it is not an ambiguous field. It's not duplicative. Okay, so I've got the order number, the order date, the item number. And again, so test yourself. You see the red squiggly line, and it's complaining because it's an ambiguous name. And where do we want to get the item number? What are our 2 choices here? We can get the item number from either the item field, item table, or the order line table. Doesn't really matter which one. Let's go ahead and we'll just work left to right. So let's get this from order line.item num. And now the squiggly line goes away until IntelliSense says that's okay. So we've got the order number, the order date, the item number, and then we need the description. Okay. And again, description is only found in one of those fields, or one of those tables, I should say. And so that is not ambiguous. And then finally, the category for each item that makes up the order. And let's run it. And sanity check, I got 12 rows. That seems reasonable. And I'm displaying only the order number, order date, item number, description, and category. Didn't ask me to order these in any other way than how they come out of the faucet naturally. And so it looks like we've met the specification and should have a full credit solution. Exercise 5 elaborates on a multi-table equi-join by adding filter criteria. Okay, our 5th exercise is based as a parallel to TAL number 11 in the current problem set. And this is going to build on what we just did. And recall the big picture, what we just did in the previous exercise was a multi-table join, so more than 2 tables. Now we're going to add in a filter. So we're going to do a multi-table equi-join and add some filter criteria. Okay. So looking at the problem statement, find the number and name of each customer that currently has an order on file for a rocking horse. This is a little bit different than the last one in that we need a customer name. So we know we're going to be working from the customer table. And what else? We are going to find the number and name of each customer that currently has an order on file. Okay, so walking down our relationships. In the customer table, I have a customer number. That customer number is used as the foreign key in the orders table, so that the orders table has the customer number. We can, sometimes it's helpful to go back and look at this. Okay, so here's our tables. And if we go take a look at the orders table, we see that there's a customer number there. So that's the linkage between those two, is the orders. But what do I need out of orders? Find the number and name of each customer that currently has an order on file. But we need to find that the order is for a rocking horse. And the orders table doesn't tell me what is being ordered. It says this is the order number and this is the customer that that ordered it. This is their customer number and there's the date. Where do I get the order detail? Well, that's going to come out of order line. And if we look at order line, indeed, that's going to provide the linkage. We see the order number to the item number, but I need the rocking horse. And rocking horse is the description of the item. So I'm going to have to walk customer to orders, orders to order line, and then order line has the item number, but in order to reconcile that with the description, which is going to be our rocking horse, I need to do that through the item number linkage on the item table. Okay. Okay, select star from, and here's all our tables. And again, you should recognize that this is getting particularly bad if I blow this join, because I'm going to have all the rows in one table times all the rows in the second table times the third times the fourth, because I've provided no linkage between them. There's no join criteria. So if I run this, okay, 17,280 rows. You definitely should have a clue there that there's something wrong. So let's go down and walk our linkages. And what's our rule of thumb? If I have 1, 2, 3, 4 tables, then there will be connecting them 1, 2, 3 equal signs in my join criteria. Right? Three equal signs join 4 things. One less equal sign than the number of tables. So let's go ahead and put in our where, and let's say customer dot customer number equals orders dot customer number. Great. I got one of the 3 joins done. And let's pick the second table linking to the third. I was careful about how I developed the list of tables, so I built a chain. Okay, you don't have to list them in the order that they're linked, but it's really helpful when you're thinking this through and designing this to go ahead and put it that way. So I've been careful, customer to orders. Now I'll link orders to order line. Okay, so orders dot, and orders has an order number that is linked to order line dot order number. Great, I got 2 equal sign in there, 2 out of the 3. So I've got those 3 tables linked by those 2 equal signs. Just keep going. And now I want to, so I've got this linked to this, linked to this. So now I need to get the linkage between order line and item. order line, and which of these fields is going to link to item? Would it be item number or order num? Well, in the items table, it's going to be item num. That's going to be the primary key over in the items table, equals item dot item num. All right. I haven't filtered yet, but this should give us the basic join, and we should get a more reasonable number of rows than 17,280. Let's test this. Okay, so there's everything, 12 rows. This is looking far more reasonable, and everything is joined and working. And now what I need to do is look at the original criteria. Find the number and name of each customer that currently has an order for a file for a rocking horse. Okay. And so all of these ands were join criteria. Now I'm going to actually add filter criteria and description. And notice that description is only found in one of those 4 tables, so I don't have to fully qualify it, although I could say items.description. It's always correct to do that. And description equals, and I'm looking for a rocking horse. Let's run this and see if I get a result. All right, so there were 2 orders that involved a rocking horse, one from Brookings Direct and one from Toys Galore, but double check, have I met the criteria yet? I said find the number and name of each customer. This has everything, so I need to go back, and now let's select only those fields that we want. So we want the customer number, and we want the customer name. And I'm getting a complaint. So here's your checkpoint question. Why? Ambiguous column name, because customer number appears in more than one of the tables. Why don't we just pull this one directly out of the customer table? And now no errors. Let's run it. And we see that Brookings Direct and Toys Galore have orders for rocking horses. Problem solved. In exercise 6, we will explore the self-join. This self-join will use an inequality to eliminate redundant or duplicative combinations. Next, we turn our attention to exercise 6, and for a parallel problem, we're using TAL number 12. And this one takes a little bit of thinking to understand because it involves one of the more curious things that you can do with a relational database, and that is you can take a table and join it to itself. Okay, so we're going to be using one table joined to itself in order to make combinations of things that are in the same list, one paired with another. Okay, so here's the problem statement. List the item number, description, and category for each pair of items that are in the same category. For example, one such pair would be item CD33 and item DL51 because the category for both items is toy. Now, here's the tricky part. Thinking about it, if I were to figure out how to solve this, and one of the outputs looks like CD33 paired with DL51, is it not true that another pairing would be DL51 with CD33? That, if I wanted all the possible combinations, then that would be indeed the answer. However, I don't want to duplicate combinations just because the order has changed. So the conundrum is, how do I make it give me CD33 and DL51, but not the reverse? Okay, well, since these 2 things are not equal, we can think about that. And whatever I do, I haven't learned the magic yet to generate the self-join so I can get the thing out of the same table joined with itself, every possible combination. But I can see once I do that, if I were to say something where basically, if this is the first thing and this is the second thing, if I were to come in here and say where first thing is greater than second thing, okay, then I would only get this combination. The DL51, D comes after C, so that would say, hey, DL51 is greater than CD33, or I could flip it around and say where first thing is, let's make it less than, okay, in which case I would get this pair, but not this second pair. So hold on to that thought. We can see that this is going to be part of the magic of eliminating the duplication. However, how do we do the magic in the first place? How do we join a table to itself? The first problem that we have with this is trying to reference the table by name. So you would say, okay, well, this is really easy. This is the item table. So I'm going to say select item dot item num. Oh, and then item dot item num. Well, wait, that's referencing the same table. That's going to be the same instance in the same order. So I need some other way to select a bunch of things from the item table, but I need to list the item table twice in order to join it to itself. But I can't say item item. That's not going to work. Here's what we're going to do. There is a feature that allows us to reference the item table with a short name. A lot of times when we have table names that are really, really long, we might reference item table as I. That way, when I have to go in and reference the I dot description, I don't have to type ITEM or the really long table name every time. Okay. In this case, I'm going to use, instead of I, how about F for first instance of item table and S as second instance of item table. So I'm going to select a bunch of stuff from item table F, item table S, and again, I have a join. I don't really want an uncontrolled Cartesian product there, so I need to say some sort of join. Where, and what shall we join them on? How about item num? That's the primary key. F dot item num equals S dot item num. And does that really work? Let's just take a look at that and see what we get. Yeah, we got 15 rows and we have everything in here twice. But let's take a look. Are we getting the pairings of categories that we want? Are we getting the pairings of items in the same category? Well, I haven't done anything to link the same category. So right now, if you look at it, I have category GME, and yeah, that one's paired GME, GME, toy, toy, puzzle, puzzle, GME, GME, toy, toy, puzzle, puzzle. But I'm not getting things ordered the way I want them to. Okay, so the other thing is I got way too much selected here. Let's simplify this a little bit. What I really want is the F item num and the F description and the S item num and the S description. And let's see, we also need the category, right? Because we're going to be proving on category. And I don't really need to put the category in there twice. So we'll just use f.category. We don't need to, it's going to be the same for s.category. And here we have Yeah, but we're seeing AH74 paired with AH74. That's not what we want. So we need to make sure that these are not equal. And what about further down here? Yeah, so we're not quite there yet. We do have the table linking to itself, but we need to add the inequalities. Okay, so from item, where item number equals item, but we don't need the item numbers to match, right? We want the item categories to match. There's our problem. Let's run that. So now we have 77 rows, so we're getting more of the combinations, although we're still getting AH74 matched with AH74, but we're also getting AH74 matched with BR23. So I have Skittles and Patience, but if I go down further, I will probably find a Patience matched with Skittles. I have to go looking for it, but it's in there. So I haven't gotten rid of the reverse, but now I'm getting all the combinations, but I don't really want the thing combined with itself. So I need to refine my where clause a little bit further. So let's say, and the first item num is less than the second item num. And that is what's going to get rid of all the duplications. So Patience matched with Patience, AH74, AH74, because the item numbers are not allowed to be the same. And moreover, because they're not just unequal, the first one has to be less, then I will not get the flipped combinations. Okay, let's give this a try. Okay, so I see Patience and Skittles, Patience and Mancala, Patience and Cribbage Board, and so forth. And if I go down and look at the Skittles, do I get Skittles turned around and mapped with Patience? No, that's been taken care of. So let's try and make this a little bit better ordered. Let's see, list the item number, description, and category for each pair of items that are in the same category. Okay, so this probably meets our requirement. I think it will be a little bit clearer if we also order by category, and then once within the category, let's just see what this looks like. Okay, so now all of our categories, all the games are first, and all the puzzles, and then all the toys. But within these, wouldn't it be nice to further order by the first item and then the second item? That'll give us a really regular pattern here. And now we can see Patience to Skittles, Mancala, Cribbage, Pick Up Sticks, Tic-Tac-Toe, and then Skittles starts pairing. And now it's really evident because we have Patience, Skittles, Mancala, but we don't have them duplicated in the first, so we aren't getting the duplicate reverse combination. So if I have Patience and Skittles, if I go down to Skittles, I will not have Skittles and Patience. So here's all the Skittles. And notice that I don't have any Patience appearing here, okay? As opposed to, what if I said instead of less than, what if I said not equal to? Just means that they're not equal. Okay, so here I have Patience and Skittles, but here I have Skittles with Patience. Okay, so that's what the magic is when we say less than. It gets rid of the duplicative, the reverse ordered pairing. A little bit hard to follow. You got to play with this one a little bit, and that's what I'm doing as I built this up. So go ahead and play with that when you do the self-join. Examples of where a self-join is really more useful. I mean, making combinations like this occasionally does come up in business. Ordered lists or combinatorial lists are important, but perhaps a more familiar example would be if you have a list of employees. Well, every employee, except maybe the chief executive officer, every employee has a supervisor. Well, every supervisor is an employee. So you have a table that has the employees that also contains all the supervisors. So that's an example of when you would do a self-join in order to find out who supervises whom. So this is a very real world situation. It's just a curious one in terms of a relational database because we don't often think about joining a table to itself. And again, in summary, the whole key to make it easy to join a table to itself is to give it an alias name. So here we've called one table copy of the item table F for first, and one table copy of the item table S for second, and then we can just refer to F equals S and F greater than or less than S, and it makes it very simple. That's it. Chew on that one for a little bit. Exercise 7 develops a multi-table equi-join with a filter field, which is not used in the displayed fields. This is intended to disabuse students of the notion that the filter criteria has to be part of the displayed fields. All right, next up is our 7th exercise, and the parallel here is TAL number 13. And the big picture objective here is, we're doing a multi-table equi-join. We've done several of those by now, but we're going to use a filter field that is not displayed. And this is one of those things, some students, for some reason, get it into their head that the filter field has to be displayed in order to be used as a filter, and that's simply not so. So this one's an important one to break us of that habit or that false belief that the filter, the logic for producing the display, has to be included in what is visible and displayed, and that is simply not the case. Okay, so we're doing a multi-table equi-join with non-displayed filter field. Okay, so in this parallel exercise, we list the order number and order date for each order placed by the customer named Johnson's Department Store. Okay, so let's take a look at the tables we're going to need. And let's say start with a select star. And we're going to need customer and order, so just 2 tables here. And then our join criteria for customers and orders we know pretty well is going to be the customer number. And tell you what, just for fun, let's use something we learned in the last exercise. Rather than having to type customer, C-U-S-T-O-M-E-R, and orders, O-R-D-E-R-S, we saw that in the self-join, we could alias the tables. How about we alias customers as C and orders as O? And now we could say where C dot, and see that behaves just like the customer name that has been aliased, even IntelliSense picks up on it. So where customer number equals O dot customer number. Do you like that? Does that make sense? Certainly saves some typing there. And if you don't like that, we can get rid of it. You don't have to use that convention. But when you start typing a whole bunch of different table names, you have joins that involve 5 or 6 tables. Boy, it can sure save you some typing and some effort. Okay, select star from customers, orders, and there's the simple 2-table join. And this should not be a blown join. We've got the linkage between those 2 tables. And let's just execute and see that that's the case. 8 rows, very reasonable number of rows. And indeed, I've got the customer information, and if I look over here, I've got the order information. So that's coming out just fine. And we need to do this for an additional filter of just Johnson's Department Store. Okay. And customer name equals, and this one is a little bit funky. Let's start by making a mistake here. JOHNSON apostrophe S Department Store. So the problem I have initially is, remember that a string literal needs to be in single quotes. But if I put it in single quotes, because there's already an embedded apostrophe, which is of course a single quote, it doesn't parse right. It has a devil of a time. So how do I tell it, hey, Mr. Query Processor, this single quote is supposed to be an apostrophe. It's not really ending the quoted material. So, what you might think is, well, I'll just use double quotes. Well, double quotes are a problem in a lot of database queries because they're just not recognized. Some query systems on some databases will allow you to do that. Some will not. But you could have the same problem with, well, what if I then needed an embedded quote in my string? So there must be some convention that allows us to tell it, hey, this literally means apostrophe. It doesn't mean the end quote. A common convention is to use a slash or a backslash. That's not working here. What we need to do is use the convention of doubling the character. So if I type it again, it says, oh, you put two single quotes in a row. I know that means that this is just an embedded apostrophe. Okay, so let's see if we've solved that problem. Do we get only Johnson's Department Store? So number 386. Yeah, okay, so far so good, except that I still haven't met spec. It says list only the order number and the order date. Okay, so no problem there. Order number, order date. And does this bother you? Because we're going to get the order number. I look way over here. I'm going to get the order number and I'm going to get the order date. So I'm going to get these two fields here. But how do you know it's Johnson's Department Store? We'll take a look. 51613 is what I should get. And I run it. And indeed, that works just fine. Some students get very bothered by the fact that this is our criteria for the filter, and this is our select. This is what we're showing, and we're running logic on a piece of the data that is not being displayed. That is okay. That's perfectly acceptable. And so I will undoubtedly be taking points off somebody who does this and just seems to believe that the customer name has to be there. And that's not right. And that is a 0 on this exercise. So get with the program, make sure you've complied with only list the order number and order date, but we're going to filter by criteria that we're not displaying Johnson's Department Store. And again, the dirty little trick here is to let it know that we mean an embedded apostrophe. We double the character. All right. In exercise 8, we will construct a union performed on two multi-table queries. For exercise 8, we're going to be using the parallel example from TAL 15. And the statement here is list the order number and order date for each order that either was placed by Almonton General Store or that contains an order line for a fire engine. There are different ways to approach this, but perhaps the easiest is to say, hey, what we're looking at is really two separate problems. List the order number and order date for each order that was placed by Almonton General Store, combined with, so instead of or, we could say the words combined with each order give me the order number and order date for each order that contains an order line for a fire engine. And let's indeed start that like two separate problems, and then recognize that when I'm generating fields of the same type, in the same position, that those line up and could be used with a union. And I can then simply do the union of the two different queries that provide that result, and I will have solved the problem. So it's a divide and conquer, and the trick here is to recognize that this is a situation in which you could use a union. Again, not perhaps the only way that the problem can be solved, but it is the way you need to solve it in this set of exercises. So we're learning to use and recognize the union. All right, so let's start this way. Select star from customer orders, and our join criteria is going to be where customer.customerNum is equal orders.customerNum. Okay, so pretty straightforward, simple two-table join. We've gotten used to those by now. And I'm seeing 8 rows, so the join is not blown. Our criteria is good. And we want to list the order number and order date. For each order that was placed by Almonton General Store. Okay, and that's our first part. And just to sanity check this, let me temporarily put the customer name in here. I'm gonna take it out in a moment. Okay, so do we believe that I've got the orders that are just for Almonton General Store? Yes, we do. So we can take that one out. And there's the first half of our problem. I'm going to copy this. And our second half is one that contains an order line for a fire engine. Okay. Now, here's the problem that I have in the second half of this, and that is where do I get the description? I can't get that out of customers, and I can't get that out of orders. So I need some more criteria in here I got to get that out of items, okay? But in order to get it out of items, I can't simply add the items table. Why not? There's the item table. And let's regress this for just a moment. Give me everything, and let's get rid of this criteria, and it'll be a little easier to see. I'm going to select just the query I want to run, and 120 rows, so I know something's not right. Well, we don't have the join for the item table, okay, where something is going to equal something in the item table. Well, what's the key of the item tables? It's item dot, oh, we've already got the where in there, and item dot item num equals, but wait, I can't link that up with anything. Why? Because in order to get the item number, I need to link this with a table that's missing. So what was our linkage there? We have customers links to orders, orders links to order line, right? And then order line links to item. So again, I have 4 tables, so I better have 4 minus 1 is 3 equal signs in my linkages in order to make sure everything is linked up. And let's see, have I got these lined up so that it's easy to see the relationship? Customer to links to orders on customer number, orders links to order line on order number, order line links to item on item number. Okay, great. Now I've got the linkage clearly in my head. So we've got customer to orders, and now I need to get link orders. Order num equals order line dot order num, and order line dot item num equals item dot item num. Okay, so now let's look at our second piece. All right, the linkage is correct. The number of rows is reasonable. So what else did we need? Our original criteria was for a fire engine. If we look over here in our description, there's an example of a record where it will have the fire engine. So let's go ahead and add that. And description equals fire engine. And let's run the second one. Okay. And there's the fire engine. Now let's go back and say we only wanted the order num and the order date, right? And let's run the second one. But now where am I getting order num from? How about we get that from orders? And let's run that. Okay, so my second query is now much more complex in that it uses multiple tables. However, the output is order number and order date. My first query, which is quite a bit simpler, gives me the results of orders from the Almonton General Store, order num and order date. Now that I have the two, I can simply glue them together. Let me get rid of the end of query, add the union, and because they're using exactly the same field types and in the same order, then they are compatible for a join, and I can take this whole thing and run it. And notice that I got 2 results back when this was generating 2 results. Wouldn't you have expected that this second one would have given you a third result? Why didn't it? Good catch. Let's think about that for a second. As a matter of fact, let's do this. If I temporarily come in here and turn all fields on and say, who was it that ordered that fire engine? Oh, it was the Almonton General Store. Notice that this is already giving me all orders for the Almonton General Store. And so it would be duplicative because this would be order number. Let's see what the order number was, 51617. And if I look at the first query, it already includes order number 51617. So we learned something interesting about union. And that is, it doesn't give us duplicates when we just use union. It gives us the distinct rows. In exercise 9, we will construct a subquery using either the all or any operator. It will be the student's job to discern whether the all operator or the any operator is appropriate. In exercise 9, we'll be using as a parallel problem number 18 from the TAL dataset. And in this case, our instructions are to list the item number, description, unit price, and category for each item that has a unit price greater than the unit price of every item in category GME. And in order to do this, we're specifically told we are to use either the all or the any operator, whichever one is appropriate. Okay, so what we're talking about is two queries working together. So we got a subquery structure. So our big picture objective here is to use a subquery with the all or any operator. And you've got to understand the difference between all and any and discern which is the correct one for this particular problem. So let's see if we can discern where our two queries are and how to break these apart. Okay, so the first thing we need to do is we need to get the price from the item table for the GME category. So let's start with what's going to be the inner query, the subquery first. Okay, so let's start really simple. Select star from item table and execute it. And there we go. And now let's see, we don't want everything. We only want where category equals GME. Okay. And let's see, we don't want everything here. We only want the price. So those are all the prices of the items that are games in the item table. Okay. Now, let's think about this. Our big picture problem was list the item number, description, unit price, and category for each item that has a unit price greater than the unit price of every. So it's got to be greater than any of these. Well, let's see. For example, if I had a price of 15, it would be greater than some. It'd be greater than $13.99, but it'd be less than $22.09. So what is it that I want, any or all? I want to find the ones that are greater than all of these, okay? So what I want is, let's start with select star from item where price is greater than all, and let's wrap this subquery in a hug, put parentheses around it. So we're going to look at everything in the item table, and if its price is higher than all those in this list, then it's going to be in our result set. Let's see if that works. So keep in mind here, let's grab the highest price here. Looks like it was 75 bucks. And execute. And every one of these in the result set is greater than 75 bucks, which is the highest price in that list. So that would be greater than all of those, right? Okay, so this does appear to be working, except we haven't met our criteria. It says list the item number, description, and unit price, which is just price, I believe. Oh, and category. List the item number, description, unit price, and category. So even though we're only comparing on the games, our category in the result set can be any. And where have I blown the, did I get, maybe I didn't select the whole query when I ran that. Yeah, okay. All right, so these all happen to be in the toy category, but they could be really from any category, but we're only comparing to the category game, and these have to be higher than all. What if we'd blown this? What if we had said any? What would our result look like? Okay, we can see that this is kind of a mess because it just has to be, if there's at least one that's cheaper, then it's going to qualify. That's not what we're saying. It has to be more expensive than all of these. And there's our solution. In exercise 10, our job will be to recognize when an outer join is required and create the correct outer join clause. All right, for our last exercise, exercise 10, our big picture objective is that you need to recognize when the specifications are indicating that you need an outer join, right? As opposed to an equi-join. So an outer join, remember we're going to use either a left join or a right join to create an outer join. And this is going to give us a situation where all of the fields in one table are used, whether or not, or fields specified in one table are used, whether or not they match the table in the, or the field in the second table that is linked. So you can have some null results. You can have some that are missing values. So sort of an imperfect kind of join. We're going to get all of the results in the first table, whether or not they're present in the second table. It would be a left outer join, or if we do a right outer join, then we're going to get all the results in the second table, the right table, whether or not they are matched in the first table. And you can see that certainly there are going to be cases where we're going to want to have that. A common one in business, we might think about things that are on order, but the orders have not necessarily shipped yet. So you're going to have some orders where the order has been placed, but there's no ship date. So that's not going to be present in the result, but we want the whole list in any event, that kind of thing. Okay, so let's go ahead and break down this problem for each item. So we're talking about the items table. List the item number, description, and the units on hand, the order number and number of units ordered. So we've got several tables involved here. All items should be included in the results. For those items that are currently not on order, the order number and number of units ordered should be left blank. So if we've got them, in the items list, they're going to be listed here whether or not we have an order for them, okay? And then finally, we're going to order the results by item number. So let's get started on picking this apart. Let's start by analyzing what tables am I going to work with. Well, I'm going to work with the item table, clearly, and we're going to work with the order line table. And let's see, the order line table, and that should be it. I think we've got it, the item table and the order line table. And how are those two related? So let's go ahead and say select star from item, order line. Now, if it were simply an equal join, an equi-join, we would be joining these on item number. Okay, but we don't want an equi-join. We want to make sure that all of the orders from, or all of the items are present, whether or not they are ordered. So if I list items first and I want all of the items, then I'm going to use a left join. If I had listed them the other way around, which would be fair, okay, then I wanted all of the items from the item table, which now appears, that's why they call it left and right, see the position relative to each other, then that would be a right join. So this could be solved with either a right join or a left join, depending on what you happen to list first. I like to do it this way. And so we're going to left join order line. And when we do this, we don't list both the tables on the same line. Select star from item, left join to order line. And instead of where, we use on item to item number equals order line to item number. And that should be a working join at this point. Let's see if it is true. Okay, I got 16 rows. Also, I'm looking to see that the items are present even if there are no orders. See that I'm getting nulls in here for some of the order stuff. So there's no order for this particular item. So the patient's game or for the Skittles game, there are no orders presently on file, but they are nevertheless appearing. So that shows me that my left join is working correctly, and I'm getting all of the items in the item table even when there are no orders for them, and that is the criteria. Otherwise, I might have reversed the join. That's one way I can quickly check. Did I get the left join, right join? Did I choose the right one? Okay. All right, so I've got the join working. Now let's go back and take a look at what else that we need to do. It says order the results by item number. And right now they may or may not, depending on the index being used, happen to fall out that way. But let's make sure that that order, that sort order is enforced and say order by item dot item number. Boy, can't type right now. There we go. Okay. And is the item number now in order? And it is. Okay. And if we'd want it the other way, of course, we could have said by item number descending. And it would be the reverse order, but that's not what we want. So it's always okay to specify ascending or descending. But if we don't specify, the default automatically becomes ascending. That's the normal. So that's exactly the same, whether we specify it or not. So it's up to you if you want to specify ascending or descending. But if you don't specify, then ascending is what is going to be used. Okay. And now for each item, list the item number, the description, the units on hand, the order number, and the number of items ordered. And I don't remember what that is, so we'll go look at what the field is for the number of items ordered. And so that's going to be in the order line table. Customer item, order line, num ordered. Okay. And again, ambiguous column here on item number. So let's qualify that we're looking for item number. And let's see here. So list the item number, description, units on hand, order number, and number of units ordered, num ordered. And all items should be included in the results. For those items that are currently not on order, the order number and number of units should be left blank. Okay. And that looks like it's got it. This concludes the lesson.